throwing a few markers this year. Kayla Overland got a marker. So, all right. I changed this problem. We turn example 6. It says water is being poured into a cylindrical container, rate of 6 centimeters cubic per second. We just slightly change it. If the radius of the container is 3 centimeters, the height is 6 centimeters, at what rate is the height increasing when there is 24 cubic centimeters of water? I think it changed that, right? You can put it somewhere else if you want to as well. So a cylindrical container, so looks like that, and it says it has a height of 6 and a radius of 3. What is the formula for volume of a cylindrical container? Volume equals, what's the area of the base? Pi r squared times the height. What are our knowns? What's the current volume? What is the current volume? 24. What is the rate at which the volume is increasing? Very good. Uh, we know the current height. We know the current radius. All right, folks. As you look at this problem, it's kind of a trick problem. As we set it up, if you were to take the derivative right now, what rule would you have to use? The product rule. However, when you use the product rule, we would come up with both an r prime and an h prime, wouldn't we? We're looking for h prime. We'll finish when we get back. Okay, so we have pi r squared h. If we were to take the derivative right now, you guys told me that you would come up with an r prime and an h prime. We are looking for h prime, but do we have any way of finding r prime? No, so let's get rid of it. And here's how we can do it. As I'm filling this level, does the height change? Does the radius change? No. Because the radius does not change, I can write this as, I can plug the 3 right in for r. 3 squared is? All right, so I have 9 pi h. You have to decide, is it changing? So look at this. As you're filling it up, does the height change as you fill it up? Yes. Does the radius of the water change as you fill it up? No. So because it doesn't change, you can plug it in right away. Okay, so we're going to take the derivative with respect to time of volume equals 9 pi h. What's the derivative of v? V prime, very good. What's the derivative of 9 pi h? 9 pi h prime. As you can see, we don't even need r, we don't even need h. Does that make sense that if you're filling up a container, if you're filling up a cylinder, that the rate at which the height increases will be the same whether it's 1 inch deep or 2 inches or 3 inches? Does that make sense? Just gonna, if the shape was like this, whoa, if it was like a beaker, that would totally be different, wouldn't it? Yeah, like a cone problem. So a volume prime is equal to 6 is equal to 9 pi h prime. And so we're going to divide both sides by 9 pi. And we had 2 over 3 pi is equal to h prime. So 2 over 3 pi, and what is our label? Centimeters per second. I will accept either or, and I will tell you that the AP exam has listed them both ways. So I can't tell you for sure how that's going to work out. If in this type of problem, I would say the AP exam would leave it like this. If they don't, they'll round it to 3 decimal places. Okay, if we flip it over, we look at problem number 9. Anybody see any farmers piling up corn or soybeans or anything, making a kind of a cone shape? You have? So this is a great type of problem that they would look at. Corn is being piled into a cone shape. So as it's piling up, the radius is changing, the diameter is changing, the height is changing, the volume is changing. All those pieces are changing, correct? So I need a formula for volume of the of the cone. What's the formula for volume of a cone? 1/3 pi r squared h. What are our knowns? This is the corn is being emptied onto a pile rate of 12 cubic feet per minute and is taking the shape of a cone. How fast is the height of the pile increasing when the pile is 6 feet high and has a base diameter of 8 feet? What are some of the knowns? H prime, we do not know. We know that H is 6. Allison? V prime is 12. How about the current radius? Thank you. If you were to take the derivative right now, which rule would you have to use? The product rule. And again, the product rule would create an R prime and an H prime. That's problematic for us because you have no way of figuring out R prime. It's changing. The radius is changing. As you add more corn, the radius will get bigger, the height will get bigger, so we can't plug it in right now. Scale, proportion, sure. That's what we're going to do. The current height is 6. The current radius is 4. So it will continue to take this shape proportionally. Think about it. When the radius becomes 8, what will the height be? 12. So the height divided by the radius is equal to 6 over 4. 4 times h is 4h. It's equal to 6r. Are we solving for r equals or h equals? Why? Because we don't know r prime and we are looking for h prime. So therefore we want h's to remain. So I divide both sides by 6 and I get 2/3 h is equal to r. So I will plug that in. The volume is equal to 1/3 pi times 2/3 h squared h. Hi there. How are we doing today? Are you going to have a good turkey day? All right. Is her name Hannah? Okay. I always want to say it, but I'm like, what if it's wrong? What if I call her Sarah? Okay. 1/3 pi h squared. Sorry. Before we take the derivative, if you took the derivative right now, and I've had students do this before, you would have to use the chain rule with the product rule. Yeah, let's not do that. Let's first create a polynomial. What's going to be the coefficient out front? Right now I have a 1/3, but after I square this, what will I get? So 4/9 times 1/3 is 4/27. And then h to what power? H cubed. We'll now take the derivative with respect to time. What's the derivative of v? V prime is equal to, and if I drop 3 in front, 12/27 will reduce to 4/9. So 4/9 times pi, h squared h prime. Good. You're so good at math. All right. V prime is 12 is equal to 4/9 pi. What is h? So that's 36 times h prime. Hey, this actually works out really nice. What's 36 divided by 9? 4. And 4 times 4 is 16. So we get 16 pi times h prime. Divide both sides by 16 pi. And 12 over 16 is 3 over 4. So 3 over 4 pi equal to h prime. Feet per minute? Super duper. Nice work. Don't you feel better knowing the answer to that problem now? Last problem. Again, there are hundreds of related rate type problems. I'm trying to show you those that are most famous. Do we use the word famous for math problems? Most relatable, most popular. This last one is one that I have seen on the AP exam. This is a classic problem. It's got a little gotcha to it right at the end. And yeah, classic. Classic like Marilyn Monroe. The League of Nations. Thank you. Wow. All right. Street light is mounted on top of a 20-foot tall pole. Shining. I was gonna say, why don't you guys come up and draw it? All right. So then we got a man. All right. We got a man walking. He's 5 feet tall, walks away from the pole at a speed of 4 feet per second along a straight path. How fast is the tip of his shadow moving when he's 30 feet from the pole? Ah! Like his shadow. I don't know. What? Oh, because the flagpole's crooked? Okay. So, what do we do? I need to come up with, make a triangle. Oh, you're on fire, Allison. Now what? Make another triangle. I like it a lot. Here we go. You got 2 triangles. Are the triangles similar? Why? Okay, so Hannah invokes the angle theorem, which says that if all the angles are the same in a shape, then the 2 shapes are proportional. And she says that she knows that the 3 angles are the same because, first of all, they have a 90-degree angle, and then they have a shared angle. And if 2 angles are the same in 2 triangles, then the 3rd angle must be the same. All right? Way to go, geometry wizard. All right. So, great. Well, can I put some pieces in place here then? Why? Why can't I write that down? Doesn't change. What else doesn't change? Man's height doesn't change, but the distance that he is away from the pole changes, and the length of the shadow changes as well. So give to me a formula that relates all these pieces together. Pythagorean theorem would be great if I was looking for a hypotenuse, but I have no interest in hypotenuse. Remember, the key word that we said was similar and proportional. Set up a proportion. Come on, best of the best. So 5 over 20. So the small triangle over the big triangle. D plus S. Yeah? Let's cross multiply. Nope, notes are optional. Subtract the 5S, I get 15. S is equal to 5D. I don't know. Right now I'm just coming up with an equation. I'm going to divide both sides by 5, so I get 3s is equal to d. All right, so that looks like a formula. It relates s and d together. What do I know right now? Okay, the distance is 30, and okay, you figured that out, that s is 10. Okay, so she figured out she's a genius that s is 10, right? Just, use 3s is equal to d. Okay, good job. What else? D prime is 4, thank you. He's walking at a speed of 4 feet per second away from the lamp pole. What are we looking for? Kind of. And I'll share that kind of after this. The derivative with respect to time of 3s is 3s prime is equal to d prime. So therefore 3s prime is equal to 4. Whoop. Do that. That would be stupid. S prime is equal to 4 over 3. What is my label? Now, the question is a little misleading. It says, how fast is the tip of a shadow moving when he's 30 feet from the pole? Remember that S prime is the length of his shadow. So that's how fast the shadow is moving away from him. It's actually moving faster than. Think about it. If you step on an escalator that's moving at the airport, that's moving at a speed of, say, 5 feet per second, and I'm walking on it at a speed of 2 feet per second, how fast am I truly moving? 7 feet per second. But relative to me, or relative to the escalator, I'm just moving at a speed of 2 feet per second. But to my wife, who's waving goodbye, have a great time in Cancun, I'm moving at a speed of 7 feet per second. See the difference? So he is moving as well. So in order to calculate how fast the shadow is moving, I must take d prime and add it to s prime. D prime is 4 plus 4 thirds, or 12 thirds plus 4 thirds is 16 thirds feet per second, or 5.3 feet per second. Kind of a nice little trick, huh? You see how, the AP exam could give you two answers. It could give you 4 thirds and 16 thirds. Oh, you come up with 4 thirds, you're like, yeah, see the answer there. And it ain't 4 thirds. You're not impressed. You know what I'm impressed by? I heard that my good friend Herbie, you guys know Herbie, right? Heard you wrote a paper on chaos theory. I wrote a paper on chaos theory as well. So, and Herbie, I want you to share with Hannah later on what chaos theory is, because she will be a better person for knowing it. So, excellent. Glad you wrote it. All right. So here's your assignment, folks. The past few days, I've assigned 1 through 12, right? First it was 1 through 7, and then 8 through 12. So total 1 through 12, 16 and 18. And then here's what I like you to do. I'd like you to add 14 to your list, and then choose 2 more. I don't care which ones they are. Once upon a time, had a student who was not the strongest math student in the world, but they stayed after about 3 days until they were able to figure out every single one of the 22 related rates problems. And it was a struggle, but they did get an A on the test. And so when I say choose 2 more, you work through any of them you want, and the answer key will be uploaded online to try to understand it. But I emailed it to myself today, so it should be posted online tonight. What? Oh, the hard copy is back on my desk. I'll put it up there in just a second, okay? All right. exactly 20 minutes.